Here are the chemicals needed to perform this chemical reaction in preparing calcium carbonate. Here on my left is 25 milliliters of 0.500 molar potassium carbonate, and on my right is 10 milliliters of 1 molar calcium chloride. When both chemicals are added to the 150 milliliter beaker, and stirred, a white solid is produced, which is calcium carbonate, along with an aqueous solution of potassium chloride. Now the precipitate observed in the 150 milliliter beaker is poured through this filtering apparatus equipped with a short stem funnel with filter paper already moistened with DI water, suspended over an iron ring, and the funnel is inside a 250 milliliter Erlenmeyer flask to collect the filtrate, where the filter paper will collect the precipitate. Now 2 10 milliliter portions of DI water are added one at a time, first to the 150 milliliter beaker, and then poured to the same glass filter to collect any precipitate present. Afterwards, remove the filter paper from the glass funnel, open it up, and using a rubber policeman, scrape off the solid from the filter paper and transfer it into a pre-weighed evaporating dish. And from that point on, place it in a preheated oven to dryness, and then cool to room temperature before weighing the evaporating dish to determine the final mass of calcium carbonate that was actually collected. Dispose the filter paper, the aqueous potassium chloride filtrate, and the solid calcium carbonate in an appropriate waste container.
Here is the setup for the filtration process after collecting the calcium carbonate solid. Now, using a rubber policeman, scrape the solid from the filter paper and transfer it into a pre-weighed evaporating dish. If necessary, add small amounts of DI water and collect any remaining solid from the filter paper into the same evaporating dish. Once completed, place the evaporating dish in a preheated oven to at least 110 degrees Celsius and leave it in the oven until complete dryness of the solid has occurred before weighing.